morning, everyone. It's a great pleasure today to have amongst us Katriona Shea for the talk. Really pleased to have you here, Katriona. Thank you so much for joining us. I've known her now for at least 2 years, probably a little bit more. She's done an amazing job on the Scenario Modeling Hub. But let me briefly introduce Katriona to others here who might not have heard about her background and her interests. She's a professor of ecology and the alumni professor in biological sciences at Penn State University. She received her bachelor's in physics from Oxford and then her PhD in theoretical population ecology from Imperial College London. And she had her postdoctoral positions in California, Australia, and then joined Penn State in 2001. She uses a wide range of empirical and quantitative methods to study ecology and management of invasive and outbreaking species in perturbed environments, with particular focus on the role of uncertainty. She's an elected fellow of the Ecological Society of America and the American Association for Advancement of Science. And let me say it again that she's been doing a phenomenal job as a part of the Scenario Modeling Hub. And what she's going to talk about today will certainly touch upon some of the ideas there. But please take it away. Thank you so much again for joining us. We are delighted to have you here.
Thank you so much for the kind invitation to come and speak to this group, some of whom I know well and some of whom I don't know at all. So I'm very delighted to meet you all. As Madhav said, I'm going to talk today about uncertainty in the management of outbreaks. And in a sense, I'm going to give you my personal story on the way to the Scenario Hub. And I will take some time about the Hub for those who don't know it, because I think it's always really interesting to see where scientific ideas arise. So as Madhav said, I wanted first to start with a general overview of my research. As Madhav said, I'm interested in uncertainty and the management of outbreaks, but I actually started after switching from physics in ecology, plant ecology. So I originally and still do a lot of work on the demography, dispersal and spread of invasive plants. I have a field system, I have students in the field, and I also do a lot on disturbance ecology. And then more interesting for this topic, I study the adaptive management of epidemiological outbreaks. Adaptive management is management with a plan for learning about the system. Because in a lot of ecological systems, there's this feeling that you need to study it first, work out what's going on, and then manage it. But you can't do that in an outbreak because it's more like a crisis situation. So there have to be ways of learning while managing. But you can do that passively, like, oh, I tried that, it didn't work. But then you waste a lot of time and effort. So the idea is to find a way to actively learn, to plan to learn while managing and still make it do as good a job as possible. And part of that is by targeting the things you need to learn to make good decisions. So at first glance, these might look quite dissimilar, but an outbreak of a plant or an insect that I worked on or on a disease conceptually is very related. And then disturbance ecology is relevant because as soon as you try to manage a system, you're disturbing it. And if you vaccinate for a disease, you are disturbing the epidemiological process. And so theory about how best to do that is actually very relevant. So I think these are intimately intertwined. At first glance, they might seem a bit less related to each other. Today, I'm going to focus on the one thread about disease that I do, but just remember I have active work on these plant invasions and then active work in bacterial systems, mostly on disturbance ecology. So what I'm thinking about in my plant systems is generally you're lucky to even have one model, right? You know, there are a lot of weeds, somebody will work on it, but it's affecting people's livelihoods, but maybe not their lives. And so it doesn't engender the same sort of panic that an outbreak of a disease like COVID could cause. Whereas in some settings, as I said, where it's urgent and really consequential, you will see very often multiple models being developed. One example is obviously weather and climate, and then we'll get back to major diseases. So you're very familiar with these ideas. This is for hurricane pathway projections. So if you can see my mouse on the hurricane projections, you can see there's lots of models, and they all project that it's going up the eastern seaboard, except this very sweet one that's wandering off across Cuba. You'll very quickly know what's right and what's wrong, right? If this one happens to be correct, something about this model is quite useful. And it's generally presented in this way where there's a sort of cloud around it, which gives you some sort of idea of where it could go, where it's most likely to go. So it's expressing what might happen, but with some uncertainty. So there's a massive literature in climate and weather, and in this case, forecasting for hurricanes. This is also happening for diseases because diseases matter. They're very consequential. So both for epidemic and endemic diseases, and both for public health and also for livestock, wildlife diseases, we're increasingly seeing multiple modelling efforts. And I give you some examples there: Ebola, Zika, COVID. The problem is, just like if you ask one person for their opinion, you get an idea. If you ask 20 people for their opinion, you just get a mess of results. It can engender considerable uncertainty, partly because it's a new outbreak. Usually that means you don't know as much as you'd like to know about the system. Think back to the beginning of COVID. We didn't even know there were asymptomatic carriers for a long time, right? So there was all this uncertainty about what could be going on. Then there was a debate about it, and now we know there are. But these uncertainties, both about what's actually going on and also about what could happen in terms of stochasticity, for example, means that this makes it really hard to reliably say what we think will happen, so in a forecast, but also it makes it really hard for managers who have to make a decision when different information is coming at them. So I'm going to go through 4 case studies in a fairly linear way, but when I do this, it isn't actually a linear story, in fact. So occasionally I will tell you where a lot of overlapping threads all happened at once. And this is my personal pathway to some of the COVID work we're doing now in the Scenario Hub that various people like Brian and Madhav know about very well because they contribute to the hub. But just be aware that a lot of other threads from other people, other scientists, have contributed to the sort of culmination of where these ideas are going. And I will acknowledge some on the way, but there are many, many more than I can mention. And so I'm going to go through 4 case studies in a fairly linear way and then give you some punchlines from all the work. So our earliest work was on foot and mouth disease, which is actually a livestock disease, in large part because I was worried about the ethical concerns around uncertainty if a human disease is involved. Because when you're learning something, there are actions you can take with livestock that you will see in this picture of bonfires of culled cows after an outbreak in the UK. Clearly, some of these options are not on the table for human diseases. So there's a lot more opportunity to learn. This earliest work was done in collaboration with Matt Ferrari, who's a professor here at Penn State. He's the director of our Centre for Infectious Disease Dynamics now. And he and I started working fairly on when he became a professor, his career here, on adaptive management, which I explained is management, but with a plan for learning about the system. And then looking at the value of information, like which information that we don't know isn't actually going to be helpful. Why waste time getting it if you can focus on information that is actually going to help you do a better job in your disease system? And I'm going to talk now about work that our wonderful postdoc, Will Probert, did. Will now works for the WHO, and he and I still collaborate actively, actually. And there are several papers, 3 of which I post here. We're going to talk about the work that I think was most important, which is about the role of objectives in outbreak management. So objectives really matter, it turns out. And the problem is, when an outbreak happens, we say we'd like to control it. But how you measure what you're trying to control turns out to really matter. So I've seen examples where, for example, with a weed outbreak, people argued about what to do, but it turned out it was because half of the group was trying to control the abundance of this new weed where it already had invaded, whereas another part of the group was focused on not letting it get into their lands because it wasn't there. And they were arguing about, well, I want to control it this way versus I want to control it that way. But it turned out it was because they were trying to achieve different things. So once they realized what was underlying their disagreement, that was easier to resolve. Because different stakeholders have these different management objectives, it means that you can actually make it quite difficult for an ultimate decision to be reached. So let me show you a schematic. You might have data for a disease outbreak like foot and mouth, and you have some potential control interventions like culling them or vaccinating them or doing some other sorts of interventions. And you may have a single predictive model that has your best information for that. If you are trying to, say, control the outbreak duration, you may find that action C is going to minimize the time that this outbreak runs. But the exact same data, control actions, and the same model, if you have a different objective, may actually mean that you would choose a different intervention. And here's an example for livestock cull. This is from actual work on foot and mouth disease. It's not just a schematic. And so we found that this was the case quite often. And foot and mouth is a disease that has caused huge outbreaks in the UK and in Japan, and the US is very worried about it. So this is part of planning for preparedness against a livestock outbreak, which would decimate our cattle industry in this country. There are multiple models for this. They're very, very different. There aren't many, but there are about 5 that exist around the world for foot and mouth disease. And if you get multiple models involved, you start to get a complete mess in terms of what the recommendations are. And here's a little caricature of what that looks like. Imagine you have 3 models and 3 possible actions. You have learned something immediately. There is a consensus across models that this third action is a bad thing to do. It could make it worse or not do anything. But there's very clear disagreement. 2 models think action 1 is better. 1 model thinks action 2 is better. And this actually is derived from a real foot and mouth example where the problem was that model 3 had a very good track record on a prior outbreak. So the decision makers were really torn. What do we do? Do we go with like 2 think this is better? So by voting, you might go with that. But this one with a track record that we admire says something else. It makes it really hard for decision makers to know what to do. And what often happens, and we did see this, naming no names, but there was a very influential COVID model early in the pandemic that pretty much was what everyone looked to. You rely on a trusted model, but you may be throwing away information, uncertainty, scientific uncertainty that would help you do a better job if you did include it. So I was very interested in ways that we could do that. But I want to take from this case study this idea that the objectives matter. So we were working on foot and mouth disease, and I still collaborate with Matt Ferrari. We have ongoing funding. We still collaborate on foot and mouth disease. But about 2014, Ebola happened, and I'm now going to talk about this. It was a huge outbreak. I'm sure you all remember it, in West Africa in 2014. Here is an image that I can only bear to show you because this 8-year-old boy, the photograph was taken by a New York Times photographer. The photographer followed up, and this boy did survive. But this was the age my children were. And images like this just make everyone horrified. And there was an outpouring of efforts to help. More than 100 models were published trying to say, what do we think will happen under different circumstances and so forth and so on. But there were major disagreements about case projections, massive versus smaller. And so we thought about this in terms of the insights we'd got from foot and mouth disease, where we thought, well, everyone's saying, oh my gosh, we've got a problem, what could happen? And I want to think about, oh my gosh, we've got a problem, what should we do? So I wanted us to think about the manager recommendations. So we went through these 100+ models, 55 of them were for population, so case projections or infection projections. And a subset of those that we could handle were 37 compartment models. And we had sent out a very gentle plea, would anyone be interested to try multi-model work here? So it's some first pass at what now is the Scenario Hub. And I got 2 lovely responses from very nice people, and 2 was clearly not going to be enough to do this properly. So we, and when I say we, I mean Dr. Shea, who was my postdoc at the time, recoded 37 individual compartment models from scratch, built them all up that we could then relate. And so she started off with the SEIR models, which is, as we know, susceptible, exposed, infectious, and removed, which is recovered or dead. And then we added in also the models that included hospitalizations, funeral states, or both. And when I say this is what the models looked like that Shea recoded, what it actually looked like was this. Okay, so quite complicated, and it took a long time. And then we put into them and we said, using this model, if you have the outbreak of a disease into a 100,000 person population, what do you think will happen? And we recapitulated what was seen in the literature. Just look at these SEIR models in the white section. These are the funeral only, hospital only, and both versions. You can see nearly everybody down to nearly nobody gets sick, right? Massive disagreement, even in a controlled setting, about what is going to happen with Ebola, despite the fact that these are all excellent scientific teams with their considered scientific opinion about what's going to happen, coded into models with the best data available that they could get hold of. So then we went and said, well, let's not ask that question. Let's ask instead, what should we do to minimize the number of cases? And when you do that, we looked at the 5 major classes of interventions that were available. So things like reducing transmission at funerals or in the community, increasing hospitalization rate. And we ranked them. And we ranked them from best in the sort of red end of the spectrum down to worst in the paler end of the spectrum. And what you can see is, and just look in the SAIR section, despite this massive disagreement about how many cases, from nearly everybody to nearly nobody, there is absolutely no disagreement in this class about what to do. The ranking is clear. And even when you look across, you might get the odd model that thinks something is more important that the others do. But there's this clear story that you should be doing reducing funeral transmission, community transmission. Okay, which is great, right? I feel like that's a massive scientific contribution. I think if you ask, what am I trying to achieve? What's my objective? Which was this lesson from foot and mouth disease. Then you might be able to answer the question. And there may be something more straightforward going on, despite the fact that how bad it will get might be all over the place. The problem is, you'll see this came out in PNAS in 2017. The outbreak happened in 2014. So the chances that we were going to be helpful was 0. Okay, so this is a great process, but utterly too slow because we had to recode everything ourselves. We couldn't get buy-in. We got 2. I'm very grateful to the 2 that offered, but there was no way that we could have done that. And so what I wanted to do was say that we think that it's more important to focus on decisions in many respects than on just the projections, though both can be immensely useful. For example, if we need more hospitals is the recommendation, then you need to know, well, how many beds? So you do need to know how much. I'm not saying it's not important. I'm just saying it's maybe not your first objective. But this implementation was just too slow. So I'm now going to talk about a demonstration project we did that then fed into the scenario hub. And this is the bit where it goes immensely non-linear because lots of things were all happening at once. One of the things that I was doing was I had been watching that with Ebola, there was actually a forecasting challenge. Then that made me aware of all the flu stuff that I hadn't been wearing. Lots of forecasting challenges using multiple models. And there have been many examples over the years. Don't get me wrong, these efforts have happened before. And so in October 2019, a few months before the COVID pandemic popped up, I started talking to Cecile Vivu. I'd met her at conferences. And as everybody who's worked with her knows, she's a wonderful person. We had amazing conversations about how could we make this faster, this Ebola process, using ideas from the sorts of forecasting multi-model challenges, but bringing in other ideas. So this was going on in the background, but also in the background, remember, I was still working on foot and mouth disease and planning for what might happen in a US outbreak of something like that, and also working on Ebola. And at this point, I want to mention Mike Runge. I've worked with Mike Runge for maybe 20 years. He's a decision theorist in the Department of Interior at the USGS. And he has actually served as the main facilitator of the COVID-19 scenario modeling hub. But he and I we started working together on endangered plants many years ago. So we've worked together for a long time. I was being frustrated about the Ebola work that we were trying to do and trying to work out how best to speed that up. And I got so frustrated, I put my stuff down one day and I thought, I know what, I'll just read one of Mike's papers. He's always got something interesting to say. It'll just clear my head. And I picked up some conservation paper he'd been working on, which was something to do with getting experts' opinions on parameterizations for models of something like polar bears or manatees, because he works on that sort of thing in his day job and when he's not doing COVID. And as I read it, I realized that he had used a method called expert elicitation, which is for getting information from multiple experts when you need to pull together best opinions, but you know that nobody knows everything. And I suddenly went, what if we did that with models instead of people? So I'm phoning him up as I'm running home and he's going, that's such a great idea. And so over this time, I've been thinking about some of these ideas. I had written a sort of 80-page document with everything I'd ever thought about, dumped into one document. But when COVID hit, I wrote to science and said, listen, we've been thinking about these things about how to do better. There's massive uncertainty. Would you be interested to hear about what we're thinking about? And we had some conversations. And so we distilled this all down to 2 pages in Science. And it was a science policy forum that came out in May of 2020. So sort of 5 months into 2 months after the WHO called a global emergency and so forth. And this all builds on ideas coming out of wildlife conservation management, and also decision theory, and also expert judgment, and also multi-model. So it's pulling in from massive amounts of literature in very big fields. And so the process, it looks like this. You have a problem and you need to know, what is my objective? To control it is not a specific enough objective. You need to say, what am I trying to do? Am I trying to minimize duration, or am I trying to minimize cases or deaths or spread to a place where this disease doesn't yet occur? You need to be specific, because that is going to affect what's going on. Then you can look at what interventions are available. And in a standard decision-making process, you would make projections probably in a single model, or maybe in a couple with very well-defined differences. And then you would use some decision analysis, and that's a sort of decision-making process. And then if you're lucky enough to be working in adaptive management, you would implement this, see what happens, and then get feedback. Should I have refined my objective? Are there interventions that we might look at, hybrids or some other sort of complexity? So this overall picture is basically structured decision-making, okay? But then this part is where we added the idea that instead of doing a single model, you would use multiple models. And we also added in the idea that you might use them from different teams, so not just recode them ourselves or write them ourselves, but actually use multiple teams, as was done in forecasting challenges, but also bring in all these ideas from expert judgment. And so what we're doing is merging these ideas from multiple fields: decision theory, multiple model projections, and expert judgment. So if you come from the expert judgment literature, the novelty is embedding this in a decision theoretic framework and having models instead of individuals. If you come from forecasting challenges, the difference is focusing more on the decision theory and setting in ways to use expert judgment, I'll mention in a second. And if you come from decision theory, the expert judgment is a little less common. So, you know, it really brings together multiple fields. And multiple models give a better expression of uncertainty, and I can provide evidence of that in a moment, but it guards against cognitive biases. And I'm sure you've all seen it. Famous person X said, this is how this is, and we should put this in the models, and everyone goes, oh, okay. And that's called dominance, you know, and I've been guilty of responding in that way. And then there are ideas about groupthink that you want to avoid. You don't want to reach a consensus prematurely because you didn't fully explore what else could be going on in the system. There's often these things called founder effects or anchoring effects, where the first suggestions are the suggestions that people tend to go with because they seem familiar by the time you come to make a decision. So there's all these different ways that cognitive biases can get in the way of decision making or even forecasting. So the science paper came out, and at the same time I'd been talking to NSF when the rapid calls came out. We got money for a case study. We had been talking to the CDC people on the calls, and I'd met with people many of you are familiar with, so Matt and Mike at CDC, and they said they'd be interested to see what we were doing, but they weren't sure. It was very hard to elicit objectives from them because stakeholders at the state and federal level had different objectives. So we ended up thinking about 5 objectives instead of choosing one single one. So cases, deaths, peak hospitalizations, probability of a new outbreak, and then a short-term economic indicator, which is slightly naive when it's very simple. It could be much more complicated, but the number of days that workplaces are closed in a county that has had an outbreak and is interested to reopen. Remember, this is very early. This was set up in April and May of 2020. So there were no vaccines. Masks were very hard to come by, were necessarily being held mostly in reserve for healthcare workers. So the only options we had were to look at interventions to do with reopening. And so we had the 2 extremes of full closure or full reopening of all workplaces, or reopening after a peak, either 2 weeks after a peak or when cases are at 5% of the peak. And so we looked at these 4, and they are necessarily 4, right, like where you would pretty much say full closure surely is going to have less than fully reopening. We understand that, but this was a demonstration trying to show what one could do with all of these things, given very little option at the time. There were very little options for intervention. So this is a summary of multiple models. And I'm going to show you what you can see is this is infections, deaths, hospitalizations, and the other measures, including days closed, ranked from dark blue is best to the worst, which is in red. So that should be easy to remember. And as I said, closed is better than open for all of these public health measures. But the exact opposite for our short-term economic indicator, of course. Now, we had put these two intermediate interventions in the strong hope that there would be some sort of win-win trade-off-y setting in the middle, where you might find something where you don't fully reopen, but you can keep some economic business going at the same time as looking after public health. And unfortunately, the trade-off is absolute, and that was not there. But these results are pretty easy to interpret for a decision maker, but the individual model results were all over the place. So this is just for one objective and one possible intervention. It's cumulative infections for just one of the scenarios, which was the fully open. And you can see that there were 17 discrete models that contributed to MODS, 17. And you can see they go from nothing to everybody, much like we saw in Ebola. The projections are all over the place. Some are extremely confident. They've got point predictions, right? So that's probably overconfident. Some of them have very wide confidence intervals, so they may be underconfident. And also notice that despite the variable projections and the miscalibration in the sense of under and over expressing uncertainty, there is all red dots bar one. There's incredibly consistent ranking of interventions, just as we saw with Ebola. But when you get the aggregate together, it's very well calibrated. And this is really important. This is I'm just flashing it up so you can really see it's all blue at the top here and all red at the bottom. These are the individual models, but you can see the color gradations as we saw for Ebola. Even though the projections are all over the place, the rankings of interventions are very similar. And then there's this complete opposite ranking for the economic indicator, and it's very tidy at the beginning and the end. We did 2 rounds using best practices from expert elicitation, where you do a first round independently, come together and discuss it. And then if you wish, you can steal ideas from other experts. If you don't, you can stick with your own scientific opinion. This is an extreme example where in round 1, despite quite clear wording about how to interpret the number of days closed, we had a lot of teams that started with the days of the forecast, but some triggered off the stay at home, some of the state of emergency, others did more complicated statistical analyses of what they actually thought workplace closures might be. So we still have discussions in the scenario hub to get rid of what we call linguistic uncertainty, where you think you're clear about your instructions, but it's not what the other party picks up. And so this removes uncertainty that would get in the way and allows us to focus on genuine scientific uncertainty about what on earth is going on in this very complex new system. And that allows us also to span across. The individual models were very miscalibrated, but if you use multiple models, you get a much better idea of the uncertainty, because it's like asking for lots of people's opinions on an important decision where you might not bother for a simple decision. You get this amazing risk quantification. So these are medians, and then 50th and 90th projection intervals. And here you can imagine this is peak hospitalizations for our county for a hospital that has 200 beds. And you want to know, am I going to have a problem? And clearly, if you fully open, the median is above that, the 200 bed strategy. But these 3, if you look at the median, are fine. But if you're worried about the risk of a problem, you can see that these 2 intermediate ones both have medians below the 200 bed, but the 50th projection interval is over the risk and under for this intervention. And so if these are the interventions that are going to happen, it allows a hospital manager to say, what is the risk of exceedance of my number of hospital beds? In which case, I need to set up a field hospital or prepare to ship my patients to other institutions. And so it allows them to plan for this situation by expressing that risk. Now, this is on medRxiv because we did the work. We tried to submit it. We submitted it once and it didn't get through. And at that point, we stopped because it served its purpose. The CDC had watched what we did, and Cecile got in touch, and Justin Lessler and various other people were all pulled together because we'd all been thinking about different ways to get at the problem of COVID in terms of longer term outbreaks. So these are the punchlines from this MODS results. We need multiple independent modelling teams to be quicker. We can reduce linguistic uncertainty to focus on scientific uncertainty. We can provide risk quantification for decision makers. And the case study, we did it in real time. It wasn't used in real time, but the demonstration was there that it was possible to fully operationalize this in a way that would be useful for decision makers like the CDC or state and federal decision makers. So as I said, this led into the Scenario Hub, with which many of you are familiar. And just for those who are not, the Scenario Modelling Hub for COVID collects and aggregates projections in an open call to models from multiple modelling teams, and we are focused on US public health outcomes, so cases, hospitalizations and deaths over usually 6 months, but sometimes longer, sometimes shorter periods, and at both the state and the national level. So not down to county like that MMODS example was, but at the level at which many decisions are made. And I contrast projections with forecasts, because forecasts are usually short term in this case, but they can be longer. But what they're focused on is what we think will happen. What we're using in the Scenario Hub is thinking about projections of what could happen if a certain set of assumptions arise. So projections dependent on a scenario. And we do these conditional and scenario assumptions about things like future use of non-pharmaceutical interventions like masking, stay-at-home orders, and vaccination campaigns once vaccination came into the setting, and also uncertainty about things like new variant arising. And I'm just showing you this slide so you can see the mammoth amount of work that's involved in this. Here's the coordination team at the top. And then here are modelling groups that have contributed projections to any round. You can see Madhav down here at the bottom. So and Brian was on the call today, and we have CDC and other collaborators. And a huge amount of effort has gone into making this work quickly and operationalizing basically these ideas from these earlier, slower efforts. So thank you. The work I'm talking about could not be possible without all of these and other collaborators. We have to update the slides so often because more people contribute, and it's just very hard to keep up with the huge number of people that help. So thank you. What the Scenario Modelling Hub does is makes projections over these longer periods, and we share our projections with the CDC, the White House, the new Centre for Outbreak Forecasting Analytics that's just been set up once that was set up, as well as the Council of State and Territorial Epidemiologists. We have presented regularly to the WHO, and they're setting up a pandemic hub based in Berlin. And so they've been seeing what we do. There's a new EU scenario hub that we've helped the team there, but provided advice to them as they set up. And obviously this information goes to health departments. We have a public website, and there's been considerable media interest. This is a sort of schematic. We've been doing evaluations up through Omicron, through round 12. We're actually just finished round 15. And it just shows you we've had a lot of rounds, but the point is we're doing it. We're doing it regularly, and we're doing it quickly enough in real time to actually be useful. And other than that, I don't really want you to take too much more from this, but it just shows you the amount of work that the teams have been doing. Let me go over a couple of our rounds that I think were particularly interesting and impactful, particularly because I'm caring about the decision side. In round 4, we studied vaccination and non-pharmaceutical intervention uptake. And we could look at low and high vaccination crossed with low or moderate NPI use. And my postdoc, Rebecca Borchering, who has just been hired by the CDC, was our facilitator with Mike Runge for the Scenario Hub. And she had an MMWR in 2021 about modelling the future of COVID, assuming no new variant, which then, of course, isn't what happened, but there were, because obviously there were new variants. And it was great because we got a lot of interest from the White House. The White House did a press briefing in May of that year by the CDC director. And then later we contributed in what I also think was a very meaningful round to the decision about vaccinating 5 to 11-year-old children. And we ran around from September to March of 2021 into 2022, where we looked at whether we do or do not get authorization for vaccination of 5 to 11-year-olds. Crossed with uncertainty. By this stage, we'd realized new variants popped up regularly. And so we thought, well, let's imagine in September, we might get a new variant in the middle of November that might be 1.5 times as transmissible. And we look eerily prescient in one sense, because pretty much Omicron showed up in November on all our radars. But, you know, Omicron was clearly much more transmissible even than this. So the scenario planning is in itself a challenge of dealing with what could happen, and are we going to find meaningful scenarios? By this stage, we'd also worked out better how to present uncertainty to decision makers. So these sort of clouds around different projection lines could express our uncertainty in different ways. And we could present cases, hospitalizations and deaths. We had 10 teams that participated. And this information was presented to the CDC's ACIP, the Advisory Committee on Immunization Practices, as it considered authorization and guidance on vaccinating 5 to 11-year-olds. And it's always very sweet. You see the slide that went into that final decision, and it's like one slide, 2 bullet points, all that work of all those people. But it does contribute to the reward side of a risk-reward analysis. We also did rapid back-to-back Omicron rounds purely for situational awareness as Omicron rose. We did one that was reported in December 2021, and then we reported again January 20. So all the teams worked through Christmas and New Year and all the holidays around that time of the year to really contribute to saying what did we think would happen. And we did indeed see a decline down through the early part of April. Looking at sort of differences in expected severity as information just came in. So this is the bit where the information is coming in and you're trying to work out what's going on as information arises. So the overall process for this scenario hub part involves multiple independent modelling teams that submit to an open call. That's quite important. Anyone is welcome that believes they have the scientific expertise. It becomes very apparent very quickly if they can't do it. So we've asked teams that could not do more than put in a point projection. If you can't express the uncertainty, that's not going to be helpful. We did it using best practices from an expert judgment. So our discussions to reduce linguistic uncertainty, to clarify what's going on so that we can focus on the real uncertainties about, say, a new variant. The 2x2 scenario design allows us to address both uncertainty and decisions. We usually do a mix of both, but you could do all or nothing, you know, only uncertainty or only decisions if that need was warranted. The group discussions, as I said, improve both individual models and the ensemble. And we find often that the individual models are generally miscalibrated. But so this between model variation is crucial. It expresses the uncertainty across experts rather than just within an expert. And I can show you in a moment, the ensemble does perform better than any individual model. And so this aggregated prediction, with its expression of uncertainty and risk, provides clear guidance for decision makers. So what we want to do is use these multiple models to embrace rather than ignore uncertainty. And instead of trying to select a single best model, multiple models can identify robust actions and important sources of uncertainty. And I'll show you in a moment that you can be very wrong if you rely on a single model only. So what we found from this was we built up the process all the way through these 4 case studies, and we now have something that is real time, repeated, and operationalized. Like, you can do this, and we could do this again. And we've now just set up a hub. When I say we, it's led by my colleague Sean Kulov at Johns Hopkins for flu. And we could do this for another outbreak if it arose. So in terms of pandemic preparedness, which is your focus, this would be very easy to do again. It's not always pretty. We're still working things out. And in the background, we're doing a lot on the science. We're thinking, for example, how to foster adoption. How do you persuade an institution or a person to take on some of these processes or interventions? And this is something that I've had in the back of my mind for years. I actually spent a sabbatical thinking about how do you persuade. And when I gave a talk for your sort of HPCE project, those ideas I explained there, it's really hard to get an individual to do something that's new and difficult in a time of crisis. And the same is true for institutions. How do we streamline that process? I'm still interested in ecology writ large, so I also think about how these ideas pertain in applied ecology, so, you know, wildlife management or environmental management and concerns. And then I'm also going to show you some of the other science that's going on in the background to make the scenario hub itself better. And I'd like to first mention my wonderful student, Emily Howerton, who's been involved with this. She has done a deep dive into how we aggregate these multiple models, right? It's a challenging process. And originally we did quantile averaging, which is, say, what the forecast hub does. But she did a dive into the theory and proposed that we should actually change to probability averaging. So you're averaging vertically instead of horizontally, which is these 2 pictures here, because of the way you think about what's going on. And when you do probability averaging, you're treating individual models as distinct hypotheses about what could happen even within a scenario. And we felt that that was better. And she has actually gone and compared that, a distribution of state level coverage, and the linear opinion pool, the probability averaging, which we use now, it nearly always performs better than the Vincenti or quantile averaging method. So around round 4, we switched our aggregation method thanks to Emily's deep dive into the literature. And if you look here, these black are the models that contributed to these rounds. And if a model does really, really well in one round, your temptation is to say, well, maybe we should just use that model. But it's very unusual for a single model to always be the best. And sometimes we even see them bouncing from best to worst. So relying on a single model for something this important, where people are dying all over the world, is, in my opinion, would be a mistake. If you've got a little outbreak of something you know really well and you've got a trusted model, then that might be much more safe. Okay, so you have to think about when you do an effort like this is massive. She's also been looking retrospectively at model and ensemble performance, and she has shown now there's all these idiosyncrasies about how do you actually quantify, the success of a scenario where the scenario itself may not have played out. But she's shown that aggregation is robust and reliable for longer term scenario projections. This is an in prep paper. The other paper is submitted. So I have the best student, Emily Howerton, which is just amazing. And she's been a core part of our scenario hub from very early days. The other thing we're doing is always still thinking about how can we make this faster? How can we make this faster, particularly for decisions? And we pulled together ideas that Will did from foot and mouth and Shea did from Ebola to think about vote processing, where what the models do is instead of providing quantification of an entire probability distribution or thinking about what the trajectories might be coming, we just ask them to rank interventions. And then you can use a variety of voting rules, which you're familiar with, the US voting rule, right? First past the post type things, versus something in Australia where there's some preference systems for second votes and so forth. And we actually assessed 4 different voting methods and found that they recapitulated what we'd found much more slowly for both Ebola and for foot and mouth disease. So combining these rules is a way to really, really do it quickly if you're going straight to a decision and not worry about what we think will happen, but rather focus on what to do. This actually just came out last Monday, and I've never published in Philosophical Transactions A before. I'm very excited. Normally I'm in the Bs for the biology, so this was quite fun. So I'm very excited about the possibilities along these lines too. So I would like to make a pitch. If you write a model for COVID or for flu, because we just set up the flu hub, please consider submitting a model to the scenario modeling hub, either for one or the other. Sadly, Rebecca Borchering, sadly for me, happily for Rebecca, she was hired by the CDC. So I'm actually looking for 2 postdocs, one to help with what Rebecca was doing in the scenario hub, the other to look at uncertainty, particularly around new variants, both hypothetical and about new variants once they actually arise and how to best streamline the input of information as a variant arises, and we're learning rapidly about what's going on. So if you have anybody who's looking for a postdoc that would be interested in these quantitative methods but also the expert judgment methods, please send them my way, because I'm very keen to hire people like that. And with that, I have finished, but what I want to tell you is I showed you how this pathway developed for me. I presented it somewhat linearly, but it really wasn't. It's all happening all at the same time. Like the foot and mouth stuff is still ongoing. We just had a paper on foot and mouth accepted recently too, so that's all happening all at the same time. But that's my pathway. But I must stress again, so many people contributed to the ideas and thoughts in the work that we're doing now at the Scenario Hub. And it is critical to realize that this is something about a big problem coming up, and lots of people trying to help. And instead of allowing us to sort of just all do it independently, we're finding a way to pull us all together and most effectively use that scientific expertise to really answer the meaningful questions that are raised by such a pandemic. So with that, I'll say thank you, and I'd be very happy to take any questions. I believe I've left enough time for questions and discussions. Thank you so much.
Thank you. As we all anticipated, it's a brilliant talk.
Thank you.
So I have 3 questions, Katriona. We have talked about this before, but I'll ask them nevertheless, partly for the audience here. And first of all, I again want to compliment you for a really good talk. Just amazing talk to bring things together. So I have 3 questions. They're all related to this. First, and in no particular order, is what constitutes a model? The reason is, we have been working with folks also from human judgment side, and that's a model too at some level. And should we, in a hub like this, include models of that kind too? And it's a question, I don't have a strong answer.
So I think mental models are models. So I have a mental model of how the world works. I maybe express it mathematically, maybe just thinking about it helps me see it. I think it can be really useful. I'm not clear how you merge truly quantitative models with just expert judgment type stuff, which you clearly know about, but I'm thinking it's possible. I haven't given that a huge amount of consideration, but I would include it because, you know, if you go to experts, there's been some work by a colleague of Nick Reich's that's been looking at just expert judgment for, say, parameterization as well, or what do you think will happen? And often that can be very useful, but there is literature also that says experts can be overconfident and it's very easy for them to be wrong. You get old and famous and you start to rest on your laurels a bit and you're like, oh, it'll be like this, it's fine. And then actually something out of the ordinary happens. So having the group to jog everyone up is really useful. The discussions are critical. I personally think it could be done. I haven't thought about merging the two, but I certainly wouldn't waste people's expertise. You know, sometimes you get an intuition and later you go back and go, oh, that's why. But at the time, it's not invaluable, right? I love my subconscious. If my subconscious gets obsessed with something, even though I would say that I haven't got time for that, why am I so interested? I always listen to my brain because invariably there's somewhere. You know, when I was a plant ecologist, I loved animal behavior talks. I'm like, I shouldn't be doing this. I'm wasting my time. But I'd always go and see them anyway. And I finally worked out all the optimal control theory is about how an animal makes decisions. We're animals. We're making decisions. Why wouldn't I look at it? Oh, my God. But it took me a while. And so I love it when I get... And I think, you know, experts have wallowed in this stuff for years. And then their opinions are actually very useful, even if it's so that you can go, I think it's wrong because of X. So I would say, yes, you should use models that are just simply verbal or mental models.
Okay, great. So my second question, I agree with you. I think how to do it is a challenge for all.
Yeah.
You said it. Second was, you know, over time, I think one of the good things about the hub is it's relatively small. We have seen in other cases, things grow. And when they grow, there are often going to be models for various reasons that are going to be wrong. They're not well thought through as much. Maybe initially by accident, person, you know, is well intentioned. But if this thing really grows, you can imagine an adversarial side of the story as well, especially when you allow humans to play into it. If the hub is going to be consequential, then people have reasons to add models that might bias you. So we should think about that. That's my sort of second question. I'll maybe state a third one because slightly related to the second question. And this again is something that I observe as we do our scenario modeling hub work, is if you have a large enough group, once grows beyond some point, then there are certain biases. So modelers don't want to stand out, right? If a large group starts going in a particular direction and there are few folks who don't believe that way, they start really questioning themselves. Am I really right? Or should I just go with the crowd because I stand out too strongly? Yeah. And we've seen this happen. So this kind of bias builds up, and maybe it's something we should think about. So I'll stop there and let.
Yeah. So models that are not so good versus models that are good but different are two obviously different questions, which is why you asked them different. So models that are not good, we have some measures for keeping them out. I've seen more extreme measures. So there's been a call by Raymond Hutu-Bessie and Saskia Denboon for something similar, where they actually asked then only for curated models. But I've seen exercises like that where you spend so long checking the models, you don't actually do the urgent work that's needed. There's probably a happy medium. So when the Scenario Hub meets in the next month for the first time in person, we are going to have some cross-model peer review for the first time, but it's not an emergency in the same way now. When it was an emergency, so if you see something that's completely rubbish, where you've got like more people sick than there are on the entire planet, right, there's some obvious ways to cut people out. But at the time, actually, I would say some of the most triggering discussions came from physicists that you were putting in models that weren't actually trained epidemiologists, but I saw people go away and think and change their minds about their models updates. So all the models got better because of those discussions. And we had a debate in MMODS, which was the case study that I ran and not with the coordination team. We had the models submit and they were always presented independently. So there was no chance of bullying If you were the model that was the weird outlier, you never felt awkward because you would know, but no one else knew it was you. And we did it fully anonymously for that reason. When the Scenario Hub was set up, we had a discussion about it. The problem is everybody knows, eventually, not everybody, but that wasn't possible. And we decided that wasn't going to be how we originally built it up. But it's possible to take these biases out. And we did it in MMODS, but we couldn't keep it going so well because of the rapid, repeated nature. But if you had a new outbreak, you could do anonymous submissions, discussion, resubmissions, also anonymous, but where you take, if you think, oh, wait, that is true, I didn't think about that, I'm going to put that in my model. Oh, no, they're an idiot. I'm not doing that. I'm sticking to my guns. Either is possible if nobody knows it's you. So that we try to sort of have that in MMODS. We don't have it in the Scenario Hub, but you could have it again if needed. So that would avoid the biases. And then there's just some strategies for getting rid of the really odd things.
Wonderful. Thanks.
Thank you.
This is amazing. I mean, I've bugged you a lot during the scenario modeling calls, but I think just getting this entire story of how this emerged. And I mean, one thing, at least as a person who came into epidemiology through this Ebola forecasting challenge and a lot of these community efforts, I just want to add one thing, which is the value of this community provides a healthy competition while you're getting a rapid literature review, almost like you're getting up-to-date information of what the state-of-the-art models are and so on. So I think that in itself is a very valuable tool for students and whoever is trying to learn in the process. So one of the questions I had is similar to what Mara was asking, but like I think this is more of, do you explicitly look for selecting for diversity of models, or is that something that, I mean, right now maybe it's limited because of participation, but is there merit in like selecting for diversity of models, especially if there is something unknown? Do you want people from different domains, a model that explicitly accounts for this, versus that? For COVID, I can imagine like a model. Yeah, so that's one. And then the next one was again partially related to models. When it starts growing, maybe is there merit in thinking about nesting these models, or thinking of, for instance, if we were doing a 2x2 design on vaccines versus variants, maybe ask a subset of groups which are good at sociology or behavior and just trying to do vaccine coverage modeling and come up with the best estimates from that, or ask them to design that axis of the scenarios, and then ask the group which is strong in biology to design the variant scenario, and then ask another subset to actually do the epi modeling. So both related, but yeah.
No, so the looking for diversity. So let me go to the grouping. So the scenario development is done by the coordination team, and the reason I'm hoping to find a postdoc to help us is because we know we need to triage that information much more quickly, both before a variant arises. It's one of the major sources of uncertainty, along with human behavior in the Scenario Hub. And so we actively identified that during, we'd sort of seen it coming, but particularly noticeable during Omicron, where we had to share, but there was no one that was curating the information, saying what's good, what isn't, chasing things up to check how good it is. So Theo did a lot of it, but there was nobody actively dedicated to that job, which is why I'm looking for someone to help us with that streamlining of information for the Scenario Hub. Yes, so there's sub-teams. I would say, definitely like to say the coordination team and the teams themselves that do the modelling, and they're not the same usually, except in some cases. So that's important. We look explicitly for diversity, which is why we considered a closed call and then just said no. It just cuts out too many bright ideas. And I would say we very much benefited from having outsiders that joined, and some of them have become more or less embedded in the process. And they learn too, and their models get better too. But they also do, I felt I did this as an ex-physicist too. I'd sometimes go, nah, that can't be right. And I'd think about it from a different point of view. And that outside perspective, I'm sure benefits, even if it's just to engender discussion and then a careful dismissal of it. But it's a considered dismissal. It's not just, I didn't even think of it or I ignored it. And so that's very valuable. So we do what we can to bring in, and we advertise, as widely as we could amongst people who at least do some modeling. And we're always trying to bring in new groups. It's because that diversity is so critical.
Thank you.
Thank you. Thanks, Rini.
Okay, thank you for the nice talk. It was really good to how the scenario modeling hub was constructed. My question is somehow related to the modern hub ones. I think that in the very, very early phase of epidemic or pandemic, sometimes the ensemble model can give a huge uncertainty, even though we aggregate all projections. And of course, it's because of uncertainty, and it will be improved. as time goes by. But do you have any suggestion for the implication of those results with a huge uncertainty in the early phase?
Yeah, so we've looked with Emily in particular, but we haven't got very results yet, but we've got some intuition. You think about things like weather forecasts. You know, the work goes in and then there's the expression of uncertainty for different audiences. So there's the person who just needs to know, do I take an umbrella today? In which case you just say 50% chance of rain and they can make their decision. And then there are farmers that are planning crops in their fields for the season and they need a slightly longer term thing, but they also need much more about like, what's my risk? Like, how bad could it get? You know, what would I lose? Like the hospital decision maker about how many beds I might need, where you do need a better quantification of the risk. So I think it's actually predicated to some degree on what audience you're going to. And that's our sort of insight at the moment. And we're working on that, but among many, many, many other things. So it's not moving particularly quickly about it. But I mentioned at one point, we thought about different ways of expressing uncertainty. So if you go to the web page and you look at older versus newer, I think they're on the web page, the old ways of looking at presenting the uncertainty is different as well, as we found out what people found actually to be useful. And then there are trimming methods. So you can trim outliers. Like, you know, when I showed you the hurricane one and one goes off Cuba, you could just say, okay, I'm going to take the 2 outliers or the N outliers. And if you exclude everything, you get down to the one in the middle. But you get, sorry, I always mix those up. Very embarrassing. But you can just think about how you trim and you can make a better decision based on what your needs are. So if you're really worried about what's the chance I have a disaster coming, and just so I have a group ready to go, versus I'm not going to worry everybody else. So I don't need to express that uncertainty for everyone else. It depends on your audience.
Thank you.
Question, have you started to apply your methods to polio or monkeypox?
We haven't. We've been looking at the monkeypox stuff just in case, but I mean, it's fascinating anyway, right? But at the moment, we could ramp up for something where it's truly needed. And if it's seen to be needed, then we will, but we haven't been asked to, so we haven't done it. It would be a very different modeling community. It isn't an STD, but it's being treated as an STD, which is interesting. I think not necessarily the best strategy, in my opinion, but that's we'll have to see. There's been some spillover outside the MSM community. Polio, fascinating one. Again, no, we haven't been asked.
One more question from the chat. You presented coverage evaluation for models in the scenario hub. Wonder if you chose a specific scenario or is this an aggregate of all scenarios, and any thoughts on how to assess error coming from the scenario misspecification?
Yeah, so my student Emily Howerton and Justin Lessler and Cecile Vibou, the presentation of one slide, it's ongoing, they're doing that. And the issue is that with short-term forecasts, you can actually evaluate off the data. We're now past some of those times, but the scenarios may not have played in the way. So we've toyed the way they actually eventuated, to finish my sentence. So we've toyed with different ways of doing that. And so the possibility is to do some weighting or to choose the one that's closest. And that paper is forthcoming. I'm not going to talk about it more because I don't want to give Emily's results away, but we are working through it very carefully to work out what's the best way to move forward. But that slide I showed to you involves thinking about all those issues, including that how to weight the scenarios or to choose a scenario which to compare with.
I just want to thank Katriona again for a great talk today. And thanks everyone for joining us today.
Thank you very
so much
Excellent
for having
talk.
me. It's been fun to talk to you and I'm very honored to be here. Thank you.
Thank you very much.
Bye-bye.